Good day, everyone. And once again, your favorite uncle is back, and we are going to be looking at still solving for quadratic equations, but this time we're going to be looking at solving for equations using substitution. So K method substitution. So if you haven't subscribed, please just make sure that you are part of the family. Hit that subscribe button and the notification bell so that you are alerted every time that we are posting a lesson. All right, without any further ado, please let's get into our lesson. Right, now, when we solve for x, all right, when we're using the K method substitution, so sometimes you find an expression where we've got something that is similar or a similar expression. So I'll take an example. So if I've got 2x squared plus 2x, okay, and this would be all squared minus 2 times x squared plus 2x, okay, minus 3. All right, so now you've got an expression like this. So we look for something that is similar. Can you note the expression that is similar in that regard? Right, of course, we've got this expression x squared plus 2x. And you'll see that if you try to expand this, what you will end up with is, the highest order of x, or, the highest power of x in this case, being 4. And in that case, it no longer is a quadratic equation, right? Now, what you would do in this case is I realize that I've got a similar expression, and so I'm going to find one thing that I'm going to actually substitute that with. So what am I going to say? I'm going to say, well, let's let x squared plus 2x be equal to k, right? So everywhere that I see x squared plus 2x, I'm going to substitute that with k. So let's start there. So you can see there in that case, so it means this is going to be k. But remember, in that case, it is squared, right? And that's minus 2 times k. All right, so I'm going to substitute that with a k. And this is minus 3. And this is equal to 0. So now what do we have? We've got k squared minus 2k minus 3, which is equal to 0. Can you see that now we're back to having a quadratic equation? All right. So in this case, what I'm simply going to do is just try to solve for k in that case, right? So I'm going to say, all right, so it means that we're going to factorize. And by the way, if you have not watched our first video on factorization, in this case, please just do yourself that favor. So in this case, the highest order of k is 2, so it's a quadratic expression or a quadratic equation. So that's going to be k and k. I'm looking for factors of 3 such that when I subtract them, they'll give me 2. Of course, that's going to be 3 and 1. If I've got a negative sign there, it tells me that the signs are not the same inside my bracket, right? So in this case, the bigger product will take the sign of the middle term. Of course, you would have known how to do this if you watched that video on, solving for quadratic equations using factorization. So in this case, that's 3 times k, which is 3k. Of course, you also have k times 1, which is k, right? So which one is the highest, or rather the bigger product? It's going to be 3k. In that case, so it means that 3k has to be negative. So in this case, so that the middle term becomes negative. So we've got k is equal to 3, or k is, obviously this is going to be 1. So k plus 1 rather. So now we've got k is equal to 3, or k is equal to negative 1. Now, please don't forget, ladies and gents, that we are not done, right? Remember, we are supposed to solve for x, right? So now I'm going to go back. Remember, we said that k is x squared plus 2x. So I'm going to take that x squared. Sorry about that. Okay, so I'm going to say x squared plus 2x is equal to, so I'm going to substitute that value for k is equal to 3, or x squared plus 2x is equal to -1. Now let's try and solve. In this case, in both instances, we have to put it in standard form. So that would be x squared plus 2x minus 3 is equal to 0. Okay, so I'm going to try and solve this one first. So factors of 3 such that when I subtract them, they give me 2. In this case, I'm going to open both brackets. The a value is 1. So in this case, that's going to be x and x. I'm going to have 3 and 1. Okay, so in this case, it means that that will be positive and that will be negative. Of course, I'm going quick at this because I've already taught this lesson, so I won't really dwell much in it. You can just go back and look at factorization and you will be assisted. So this is going to be x is equal to -3 or x is equal to 1. Okay, right, we'll come back to that a little bit later, right? So in this case, let's solve for the one on the right. So we've got x squared plus 2x plus 1 is equal to 0. Now, of course, I tried to teach this in special cases. I can already see that that is actually one of those special cases where x plus 1 squared is equal to 0. Now, you can already see that this is a product, this is a square, a perfect square, that's a perfect square. And the middle term is a sum of, in this case, it's a sum of taking the two square roots together. So in this case, we've got x plus 1, which is x plus 1 squared, right? So in this case, it means that x would therefore be equal to -1. So you only find one root on this one, right? So in some instances, it might be necessary for you to actually go back just for you to check, especially when we're dealing with surds or where you are dealing with fractions. But in this case, we can accept that all of those are actually solutions. All right. So now let's go on to the next one. I want us to take something with a fraction in it, and I'd like to see how we might explore that, right? So now, say for argument's sake, ladies and gents, we were given, so let's take our second example, and we are given x squared. And by the way, I'm going to still teach on fractions, so please don't stress too much about it. I just want you to understand the gist of K-method substitution. So let's say x squared plus 3x minus 8 minus, we subtract 20 over x squared plus 3x. Okay, and this is equal to 20, right? Now, once again, I realize, okay, we've got a fraction, and if we try to multiply by the LCD in this case, we would end up with an even more complex equation, right? But in this case, I realize there is a similar expression. Now, I'm teaching somewhat how to deal with fractions in this case, but I won't be as comprehensive as I should. I will have a separate lesson for that. Right, so in this case, I've got, right, so what are we going to do? We've got a similar expression, okay? So I'm going to say let x squared plus 3x equal to k. So I'm going to substitute that expression with a k. And in this case, by the way, it means that x squared plus 3x cannot be equal to 0, right? So we must keep that in mind, okay? Cannot be equal to 0. Why? Because remember, if I have a 0 in the denominator, it actually, the number becomes undefined, or in this case, it becomes so big that it becomes infinity. So in that case, you don't have a solution, right? So we're going to say, all right, so it means that I'm going to substitute that first expression there. Okay, let me just do that in color. So I'm going to substitute that and that over there to make it, into something that we all can work with. Okay, so that's going to be k, right, minus 8 subtract 20 over k, and this is equal to 0. Now, please, ladies and gents, once I've got an equation in this case with a denominator there, right, or rather an expression with a denominator there, right? So it means in this case, if I were to take these as fractions, all of them have got a denominator of 1, with the exception of this fraction over here, right? So now what is my LCD, right? You can take the LCD as a product of all your denominators. So in this case, you've got 1 times 1 times k, right? So now it means that your lowest common denominator is actually equal to k, which is there at the bottom, right? So what you are going to do, if it's an equation, you are going to multiply throughout by the LCD, right? So it means you multiply everything in your expression by the LCD, which means you're going to multiply that by k, right? But remember, what you do on the left, you also do on the right, so that everything balances out, right? So now we're going to substitute into the, rather multiply into the bracket, k multiplied by k, that will give me k squared, right? K multiplied by 8, that will give me negative 8 rather, that will give me negative 8k, and k multiplied by negative 20 over k. So what will happen? It means the 2 will actually cancel out, okay? So you can think about it this way. You've got k over 1 multiplied by 20 over k, right? So what happens? The k at the bottom, k at the top, they cancel each other. So I'm left with 20 over 1, which is actually equal to 20. So in this case, this is minus 20. And in this case, remember, on the right hand side, what's going to happen? I am going to have 0 multiplied by k, and that will still give me 0, right? So now we're back to normal factorization. Okay, so factors of 20 such that when I subtract them rather, they give me 8, right? So coefficient of k is a 1, so that's going to be k and k over there. What are those factors? I'm sure you can already think about them. It's 10 and 2, right? 10 multiplied by 2 gives me 20, and 10 minus 2 will give me 8, okay? So now we know that the brackets have got different signs. Why? Because our constant term is negative. So it means that now the bigger product must take the sign of the middle term. In this case, we're going to just simply say 10 multiplied by k, that's 10k, and k multiplied by 2, that's 2k, okay? So which one is the bigger product? It's definitely 10k. So 10k must be negative. So it means that I'm going to make this one negative 10, and so that becomes positive 2. Okay, right. I hope that you're getting this, ladies and gents. Of course, it does require a bit of practice. Okay, so we've got k being equal to 10, or k being equal to negative 2. Now remember what our restriction was, or in fact I was supposed to put our restriction there, that k, it means that k cannot be equal to 0. So none of those solutions were actually 0, okay? So what am I going to do? I am going to say, all right, now that I've found the value of k, so it means that I can now substitute back. Remember we said x squared plus 3x is k, right? So it means now x squared plus 3x is equal to 10, or x squared plus 3x is equal to negative 2. So let's try and solve the one on the left first. So that's going to be x squared plus 3x, okay, minus 10 rather, is equal to 0. So factors of 10 such that when I subtract them, they'll give me 3. That would be 5 and 2. Okay, so that would be x and x. That would be 5 and 2. Okay, so please remember, in this case, I've got a negative sign there. It means that the signs inside my bracket are the same. Are different. Okay, and the bigger product takes on the sign of the middle term. The bigger product is 5 times x is 5x, and the other one is 2 times x, which is 2x. Definitely 5x is bigger, so in that case it has to be positive. So that will be positive, and that will be negative over there, right? So in this case, we're going to have x is equal to 5 or x is equal to negative, or rather positive 2. Okay, right, so those are my solutions over there. Okay, now solving this one, we're going to have x squared plus 3x is rather plus 2. Apologies there. Okay, so that's plus 2, which is equal to 0. So factors of 2 such that when I add them, give me 3. Of course, that's 2 and 1. Okay, so that will be x and x. That will be 2 and 1. And so in this case, it means that if I've got a positive sign there, it means that the signs inside my bracket are the same. And what is that sign? It will be the sign of the middle term. So that will be plus and plus. And so x would be equal to negative 2, or x is equal to negative 1. And if you want to, you can go back and substitute those values to check if they will not give you 0. Okay, if one of them does, then it means that that value is not applicable. But I mean, I can already tell that none of them will actually give you 0. Okay, right, ladies and gents, that is how you would do a K-method substitution, right, given a fraction. Now, just one thing that I just wanted to indicate to you, that K-method substitution, okay, so this will be somewhat the last one that I go through with you, that sometimes it does somewhat feature in exponents, right? Now, let me just show you something that, how we can actually apply this. And you need to be very careful sometimes, right? So we can have, let's say, 2x squared plus 5x, right, all squared, minus, now I am going to actually say, so minus 10x squared minus 25x, right, minus 14, and this is equal to 0. Now, ladies and gents, you have to be careful, right, when you find something that may not be obviously a K substitution, but in this case it does have somewhat intonations of it. Now look at this. You've got 2x squared plus 5x, and it doesn't seem like there's anything else similar until you really zero in a little bit. So look at this. You've got 2x squared plus 5x, which is all squared, minus, now, if I take out the common factor there, right, do you realize that you've got a common factor that is 5? Okay, you can say 5x, but in this case, remember, I'm trying to make it look like this one. So I have a common factor, which is 5. So I'm going to say minus 5 into, now, negative 5 times what will give me negative 10x squared? That will be 2x squared. If I multiply those two, they give me negative 10x squared again, right? And in this case, negative 5 multiplied by what will give me negative 25? That will give me 5x, right? So in this case, that's minus 14 is equal to 0. Now notice, right, you've got something that's similar there, right? So I won't work this out throughout, but I just wanted you to see it. Of course, you are going to finish this off. You are therefore going to say let 2x squared plus 5x equal to k. And you can obviously substitute and work it out. Please, if you can, just give me a comment there and let me know what you found as your final answer. Okay, right. Just one last case that I would like to show you, right? Now, sometimes what we may find, okay, I'm just going to take a very simple example, right? So let's say we're given something like y squared minus y minus 3, and we are told that this is equal to 9 over. Now, what may be done is that we can now say, okay, so this would be equal to negative, or in fact, let me just write it the other way around. Let's say 3 minus, or rather 3 plus y minus y squared, something like this, okay? Now, you must be very careful, ladies and gents, okay? Now, you would say to me, oh, but, well, this doesn't look the same, right? But I want you to really look at it, okay? In this case, you've got, something that may not necessarily be obviously similar, okay? In fact, what they may do at times is that they can actually put a negative there. Okay, let me just put a negative there. So we can say, look, this is going to be y squared minus y minus 3. But you can see that what you have at the bottom there does not necessarily, it's not exactly the same, because you've got positive y squared, you've got negative y squared there, right? But if you really, really look deeply, right? What if I did the following? I had negative 9 here, right? And I say, look, let's take out negative 1 as a common factor over there, right? So negative 1 as a common factor, what do I actually end up with? It will be negative 3, right? Because a negative times a negative will still give me that positive 3 there, right? That's again, right? I've got a positive there, so that would be negative y. It means everything changes sign, right? And then I've got plus y squared, okay? Right, now, if I just change that around a little bit, negative 9 divided by negative, right? Let's change that around. What does it become? Y squared minus y, actually, yeah, minus y. So that's y squared minus y minus 3, right? Okay, and what do you notice? It's exactly the same as what you have on the left-hand side, okay? So in this case, what am I going to do? I'm going to say, well, a negative divided by negative actually gives me a positive. So I'm going to have 9 divided by y squared minus y minus 3, right? I'm dragging this because I'm teaching actually another principle here, right? So what am I going to do? Okay, let y squared minus y minus 3 equal to k. And so what are we going to do? Just substitute. So we're going to have k is equal to 9 over k. And by the way, I almost forgot to mention that y squared minus y minus 3 cannot be equal to 0, right? Meaning that k cannot be equal to 0 in this case, right? And what am I going to do? Again, you've got a fraction there. Our LCD is k. So LCD is k. So multiply by the LCD throughout. So it means in this case, I'm going to take that whole thing multiplied by k. But what I do on the left, I do on the right. So that's going to be multiplied by k. So what do I have? I've got k squared is equal to, remember those two cancel out, so k squared is equal to 9. So you can say, well, it means that k is, if we take the square root on either side, please remember that's plus or minus, so it means that k is plus or minus 3, right? And of course, you know what to do from here on, right? You're going to just substitute there. Please do work it out and let me know what is your final answer. All right, now the last one that I want you guys to do, okay, as a homework, okay, or some kind of assessment. In this case, you can say, well, that's y into y minus 3, and which is equal to 14. All right, please just try and work it out in this case and let me know what you find. I want to leave it here, ladies and gents. Please, if you haven't subscribed, please make sure you do the right thing. Your favorite uncle will continue to give you some good content when it comes to maths and science. But of course, you can always follow us on our socials. It's at _Mlungisi Nkosi on Instagram. It's Mlungisi Nkosi ZA on Facebook, and _Mlungisi Nkosi on TikTok. And of course, you can always look out for our lessons here on YouTube. Otherwise, ladies and gents, from me for now, I'll see you guys next time. Sharp.